Okay, well, there were supposed to be two parts, but my cell phone quit videoing there for some unexplained reason. So I have to back up here and pick up where I left off. I was just saying that we know that our vertex is at 2, 4 using the vertex formula. So now we can use the information about a equal negative 2. So normally we would go over 1 and up 1. But we use the value of a to modify this parabola. So instead of up 1, it's times negative 2 or down 2. So over 1, and instead of up 1, it goes down 2. Normally we'd go over 2 and up 4. Right, over 2 and up 4 because we're talking about x squared, so we're squaring that. But now we multiply that by negative 2 and it goes down 8. So that goes over 1, 2 and down 1, 2, 3, 4, 5, 6, 7, 8. And if we did 3, you could see that would be down 18. So that's going to be another 10. There's no way we could do that on this graph, but it means that when we draw the parabola, that it's not even going to get to the next grid line. And parabolas are symmetrical, so it should look like this, like it's going through those points. Always a good idea, actually, to draw the points that you're going to draw it through so you don't just scribble everywhere. But you have a guide, you have a target for where you're going. All right, next one, write the equation of the parabola for the form in vertex form, given a equals 2 and vertex is negative 5, 7. So unless you've memorized it, you probably should have vertex form on your note sheet, and also what these things mean. So a is the multiplier that changes it, makes it wider or narrower. H is the x value of the vertex, k is the y value of the vertex. So this must mean that if a equals 2, that goes here, h is negative 5. So x minus h is going to be x minus negative 5 or x plus 5. And then plus k. So here's k, plus 7. So there is your equation in vertex form. The next one says, how many solutions does this equation have? Notice we're not asking you for what the solutions are. That'll be in a different problem. This one just asks you to recognize that when we have an equation with x squared in it, that unless the answer is 0, it's going to have two solutions because you're either going to have a positive or a negative. So if we divide both sides by 4, we get x squared equals 16. Therefore, x equals either the positive or negative square root of 16, or 4. Right? Because negative 4 times negative 4 is 16, or positive 4 times positive 4 is 16. And then 16 times 4, we multiply that again, we get 64. So it works backwards either way if you put negative or positive 4 in. So the question to how many solutions does it have is, excuse me, not x equals, it has 2 solutions. And what are those solutions? They're negative 4 and positive 4, but we're counting the number of solutions as 2. Here we say solve for x. A couple different ways we could do this. We could use the square root method, add 25 to both sides, and we could say 4x squared equals 25. Take the square root of both sides. 2x equals plus or minus 5, so x equals plus or minus 5 halves. Or we can factor it. This is a difference of squares. 2x plus 5 times 2x minus 5 equals 0. So either 2x plus 5 equals 0 or 2x minus 5 equals 0. So solve for x. X equals 5 halves, or 2x equals negative 5 divided by 2. x equals negative 5 halves. So you can see that works out either way. Solve the quadratic equation here by factoring. Now, as we learned, we can solve it with just the quadratic formula. Factoring, though, may prove to be a more direct method or simpler method because these are numbers that they'll scale up really big, and you've got the plus or the negative b and the b squared minus 4ac. Lots of calculation that we could introduce error in. So I'm going to suggest you actually do this by factoring, but any method will work because, of course, it's a multiple choice final, so you get to decide whether what method to use, and as long as you get the right answer, it'll be there. So this is how we do that. We say our product is A times C, so A equals 5, B equals negative 17, and C equals negative 12. Our sum is negative 17, so therefore our product is negative 60. So we're looking for a pair of numbers that multiply to get negative 60 and add to get 17. That doesn't come to mind right off the top of my head, so I'm going to do this. The factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15. I'm getting closer. Remember that because it's negative 60, that one of these is going to be negative, so I'm going to be subtracting. So the difference of here would be 59. The difference of this would be, right, this difference. 59, 28, 17. Oh, hey, I did find it. 17, 11. So I could keep going with factors of 60, right? 6 and 10. But here's the one that I'm looking for. And then since b is negative 17, I know that it must be negative 20 and positive 3. So putting this back into the box, we have 5x squared, negative 12, and then we have negative 20x and 3x. And we factor these rows and columns. So I can factor out a negative 4 from here, and I can factor out a 3 from here. Here I can factor out a 5x, and this I can factor out an x. So I have x minus 4 over 5x plus 3. I notice there's a typo here. This should be 0, and we will make sure that's correct in the final so it's not confusing. So we're saying this equals 0. So either x minus 4 equals 0 or 5x plus 3 equals 0. So either x equals 4 or x equals negative 3/5. Solve 8x minus 48 equals 0. We could do this a number of different ways. We could factor. Maybe do the square root method. I'm going to try this. I notice I can divide everything by 8. So this becomes x squared minus 48 divided by 8 is 6 equals 0. So that means I can use the square root method. X squared equals 6. So x equals either the positive square root of 6 or negative square root of 6. I'm going to leave things in the final exam in radical form, but if you're wondering what does this mean, that means it either equals negative 2.45 or positive 2.45. All right, number 26. Solve this. Select all the answers that are true. This is just a clue that we're going to have, because we have a quadratic equation, we're going to have two possible answers, and so you have to make sure you choose the correct two. This, to me, looks like it's perfectly set up for square root method because I've got it's already factored into a perfect square. So it's sort of like I've already done the hard part of completing the square. But I don't want to take the square root of this yet because I've got a 3. So let's divide both sides by 3. 147 divided by 3 equals 49. So x plus 3 quantity squared equals 49. Now I can take the square root of both sides. X plus 3 equals, right, I took the square root of a squared expression, so that gives me that, equals 7, or x plus 3 equals negative 7. So either x equals 4 or x equals negative 10. That means I would have to choose 4 and negative 10 to be correct. All right, complete the square. 9x squared minus 24x plus what will give me a perfect square trinomial? We've learned the formula b squared over 4a as the third term, right? C equals, so a equals 9, b equals negative 24. So negative 24 squared is going to be the same as positive 24 squared. So I've got 576 over 4 times a, 36. That gives me 16. That's all you're asked to do. This is a perfect square. It happens to be 3x minus 4 squared. But that's extra, or that's not required. This is our answer. 16. Solve the equation. This is probably one of the longest ones that we have to do, which is first we have to turn this into standard form. Then we have to bring the 9 over and combine like terms, and then we'll have an equal 0, and then we can solve it. So box this one out. X squared minus 5x plus 3x minus 15. So x squared minus 5x plus 3x minus 15 equals negative 9. So all I did was multiply these together and take them out of factored form. Now we're going to combine like terms. X squared minus 5x plus 3x. This would be minus 2x minus 15 equals minus 9. So now we add 9 to both sides. X squared minus 2x minus 6 equals 0. All right, so can I factor this? Product of negative 6, sum of negative 2. Let's see, products of negative 6 are going to be either 1 and 6 or 2 and 3, and I'm looking at them being negatives. That means one of them is a negative number, which means I'm subtracting. So 6 minus 1 or 3 minus 2 does not give me 2. So that means that the only way to solve this one is the quadratic formula. So a equals 1, b equals negative 2, c equals negative 6. Make sure you have the quadratic formula on your note sheet. Here it is. Also, don't forget this negative b. So if b, so you might even want to do this. B equals negative 2, then right underneath that say then negative b equals 2. See, this is going to be 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 6. All over 2 times 1. So order of operations in here, we have to do the inside the square root before we can calculate that. And we have to do the exponent, the multiplying, and then the subtracting. So this is square root of 4 plus 24. So 2 plus or minus the square root of over 2. We haven't worked on simplifying square roots without just calculating the decimals, so that's what I'm going to expect from you to do. Square root of 28 is, so this is 2 plus or minus 5.29, just about, over 2. So that's about 3.65, or 2 minus the square root of 29 divided by 2, negative 1.69. A kicker kicks a football on a kickoff. The quadratic function h of t equals negative 10t plus 40t gives the time t seconds when the football is at height 0 meters. That doesn't make sense. We should say starts at a height of 0 meters. So, gives the time t seconds when the football is at meters. This whole wording to me is very confusing. So let me just rewrite this. What we're saying is this function gives the height of the football at t seconds. So how long does it take the football to return to the ground? We're saying, what's the value of t when h is 0? So 0, the height, equals negative 10t squared plus 40t. How do we find t? Well, first thing I can do is I can factor out a 10, or more properly say, I can actually divide everything by negative 10. That's the nice thing of having it equal to 0, is you can just say, oh, I'll divide everything, and 0 divided by anything is still 0. So I've got 0 equals t squared minus 4t. And now we can use the square root method. T squared equals 4t. Excuse me, we can't use the square root method. I think I'm bogging down on the math and the review. So, but that's normal. Normally you can, that can happen. So you just take a breath and you say, all right, let's refocus. T squared minus 4t equals 0. I can't put the 4t over here because then I have a t on both sides. So I can complete the square and use the square root method, or I can factor and use the zero product property. I'm going to show you completing the square because that's probably the one you're most familiar with. So what I'm going to say is, what do I add to both sides in order to make this a perfect square trinomial? Formally, we could say this is b squared over 4a. So that's negative 4 squared, 16, over 4, which is 4. So that means we have to add 4 to both sides. That means we have t minus 2 squared equals 4, because this whole expression factors into t minus 2 squared. So t equals, excuse me, not t equals, t minus 2, we take the square root of both sides, equals positive or negative square root of 4, or 2, or negative 2. So either t equals 4 or t equals 0. This is what we would expect because if a kicker is kicking a football, right, it starts at the ground at 0 and goes up and lands again. So there are two places. So time equals 4 seconds is what we'd expect. The other way to do this, t squared minus 4t equals 0, is to factor the expression, and that would look like this. Factor out a t, and you'd have t minus 4 equals 0, and then use the zero product property. Either t equals 0 or t minus 4 equals 0. So t equals 4. All right, last one. What are the solutions to the equation? Negative 5x squared minus 4x plus 5 equals 3. So a quadratic equation, we have to subtract 3 from both sides in order to get it equal to 0. 5x squared minus 4x plus 2. 5 times 2 is 10, so the product is 10. The sum is negative 4. 10. Are there any products of 10 that would give us, and it's positive 10, that would give us negative 4? Well, no, it's only 10 and 1, which would give us 11, or 5 and 2, which would give us 7. So this is not going to factor, so we have to put this in the quadratic formula. So a equals 5, b equals negative 4, c equals 2, so x equals negative b. Plus or minus the